Hello everyone. After making 3D design of gear in the previous video, in this video I'll show you how to analyze gear bending stress on the tooth root. I use transient structural to simulate the movement of the gear. Before the simulation, first thing we should do is defining the contact of driver gear and driven gear. Select the top land and the tooth curve of the driver tooth. Choose faces with the same area. Go to Group and create NS. Repeat the process on the big gear. Let's start the simulation process. To ease the simulation, I'll make the driver gear to a rigid body and keep the driven gear flexible. Your material will be structural steel by default. You can also change the material of the gears by clicking this option. Sometimes you'll have a bug like my ANSYS, but don't worry, you can still change it on Materials option. Select the material you want to use. Create material assignment, then select the gears. Next, we're defining the contact of both gear. Select Contact, Frictional. Change the scoping method to Named Section. Use Contact 1 as target and Contact 2 as contact. You can also change the friction coefficient. Make a revolute joint on the both gear so the gear won't move to any axis. Just rotate through Z-axis. Now you can mesh the gears into small elements. You can leave the mesh size as default or change as you desire. Because I want to analyze the tooth root, I have to make a good mesh around the root. As you can see, the driver gear body isn't meshed because I change it to rigid body and only the contact surface has mesh. Also, the root mesh is not good enough. So I'll make it better using some meshing tools. Use mesh sizing on the contact section 1 and 2. I use form for the driver gear and thream for the driven gear. You can also make a new named section on ANSYS Mechanical by clicking the line or faces. Create named section. Use sizing mesh on the root. Type sizing mesh by number of divisions. Use multi-zone mesh on the driven gear to make the mesh elements have a structured shape. I think the mesh is better than before, and now I can define the load in setting the time step. Drag revolute joint from contact to transient structural menu. I'll use 3-step simulation. Defining step end time 0.1s for the first step, 0.15s for second step, 0.2s for third step. Next is time step. Select all data on the table. Now set initial time step 1-3, minimum time step 1-4, maximum time step 1-2. With this time step, I can get enough data for the bending stress analyze. Change type joint load 1 to rotation velocity. (150 rotation per minute constant counterclockwise). For the joint load 2, I use moment load 400 Newton-meter constant clockwise. The direction of rotation is not correct. You can change from positive moment to negative moment. The last step is solving the iteration. You can plot kinetic energy, equivalent stress, and deformation of the gear during the iteration process. Press Solve to start the iteration. There will be some message during the solving process. You can ignore some warning as it doesn't really affect the iteration, but it'll be better if you can solve the problem so the warning will be gone. Set the stress and deformation plot trackers to automatic. The kinetic energy will appear after one of the iterations solved. At first, the kinetic energy spiked really high from sudden rotation, but it'll be on the constant line after a few iterations.
After the solving ended, I got some data to be analyzed. I'll choose maximum principal stress, linearized maximum principal stress, and linearized equivalent stress. I'll retrieve the result of maximum principal stress to see the time that have biggest stress on the tooth root. Based on the previous kinetic energy, its kinetic energy is stable after 0.025 seconds, so I'll take the time after 0.025 seconds. Copy the time. Now for the linearized stresses, I have to make a path on the root surface. Use vertex selection, click on the edge of the root surface. Right-click on the geometry, insert, construction geometry, path. Make sure you make the path on the exact location of the max principal stress. Change the path location on linearized stress. Evaluate all result. Now you can get bending stress, membrane, peak stresses data on the path that I have made. That's all the process how to analyze bending stress on the gear using ANSYS Transient Structural. Thank you for watching. Hope it can help.